This course will cover an introduction to serializer-deserializer technology, or SerDes for short. This technology is used for high-speed data transmission. Maxim's SerDes solutions are classified as GMSL, Gigabit Multimedia Serial Link. The first generation of products are designated GMSL1, and upcoming products with additional features are called GMSL2. This course discusses the architecture and features mostly found in GMSL1 products. This training will cover an overview of SerDes terminology and general concepts, Maxim's GMSL forward and reverse channel architecture, different features offered in Maxim GMSL SerDes products, and a summary of current GMSL products. This is meant as an introduction to a complex technology with quickly evolving features. In high bandwidth applications, data is often carried over a parallel bus. Serializers work by converting a parallel data stream into a serial data stream at much higher frequency, and deserializers are used to convert the received serial data back into a parallel data stream. Camera and display systems are great applications for SerDes pairs. If a high-resolution camera and its display are separated by even a few feet, a substantial amount of wiring is required to route the data. As the bus width and link distance increase, the size, weight, and cost of cabling becomes a limiting factor. Signal integrity and EMI are also concerns when considering the number of data edge transitions occurring on the data bus. Instead of running many wires from the camera to the display unit, customers can use a Maxim GMSL SerDes pair to run a single coaxial or shielded twisted pair (STP) cable between the camera and display unit. Using a single coax or STP, sometimes referred to as a shielded twisted quad, for power, ground, and differential data, reduces cabling cost, weight, and EMI while increasing the reliability and link distance. There is an increasing trend in cars equipped with multiple Advanced Driver Assistance Systems, or ADAS. ADAS systems, when designed correctly, improve car and road safety. ADAS systems include backup assistance, surround view, road sign detection, blind spot indication, and more. In some cases, vehicles can take over certain functions such as steering, braking, or accelerating automatically. In the United States, Michigan has already introduced legislation which would allow driving services to introduce completely autonomous cars. By May of 2018, most new vehicles will be required to have a backup camera. The trend is increasing the number of displays throughout each vehicle, with more data being used to interpret vehicle and road information, as well as passenger entertainment. These systems are referred to as infotainment. Car manufacturers are looking at replacing side mirrors and rear-view mirrors with display monitors. Screen resolutions supported include HD and 4K UHD, which is 4,000 by 2,000 pixels. Camera image sensors are increasing in resolution as well, with 4K image sensors at 60 frames per second, becoming more popular. In summary, this results in a need to send an ever-increasing amount of data throughout modern vehicles, which is why Maxim SerDes products are utilized in automotive applications. The forward and reverse data channels are central to the GMSL SerDes technology, as shown in this video display application. Data is sent in both directions on the same cable by utilizing different frequency bands for each direction. The data clocked into the serializer is sent across the forward channel in encoded packets of 30 or 40 bits for GMSL1. The forward channel packets can include parallel video, a pixel clock, I2S audio, GPIO, and I2C or UART control data. The reverse channel can send GPIO, I2C UART data, and in some cases video from the deserializer side to the serializer with reduced bandwidth. Several types of cable are supported. In the video display application shown, a shielded twisted pair is used as the serial link cable. The high-speed forward channel used for video data is serialized into packets of 30 or 40 bits. The data packets contain the video data for each pixel, as well as synchronization, control, and auxiliary data bits. Additionally, 8B/10B encoding is used to minimize offset errors and ensure clock recovery, and uses 10 bits of serial data to represent 8 bits of real information. Thus, when using 8B/10B encoding, 30-bit packets contain 24 bits of data, and 40-bit packets contain 32 bits of data. One color format, RGB666, contains 18 bits of color information per pixel. When combined with bits used for frame alignment, auxiliary data, and encoding, the video data ends up in 30-bit packets. For greater color depth, RGB888 is used, which is another common format. RGB888 is 24 bits of video data per pixel. When combined with the control/auxiliary data bits and encoded, this video data ends up in 40-bit packets. When discussing camera and display SerDes applications, an important parameter to consider is the pixel clock. The pixel clock is the rate at which an image sensor outputs information from each pixel. The required pixel clock rate is used to determine if a SerDes part has enough bandwidth for a given application. To calculate the pixel clock, or P clock, from an image resolution, multiply the number of rows, the number of columns, the frame rate, and the blanking factor. In the example given, a typical 1920 by 720 display with 60 frames per second update rate needs a P clock of 103.68 MHz. If the serializer sends 30-bit packets, this requires a 3.125 gigabit per second data rate. As mentioned before, 8B/10B encoding is used in all Maxim GMSL SerDes pairs to increase reliability of the link. Since only a single data line is transmitted, the sample clock must be recovered from the data signal. To do this, the receiver in the deserializer relies on edge transitions in the incoming data signal to extract the clock. If long streams of ones or zeros are transmitted, the embedded clock signal cannot be recovered. 8B/10B encoding avoids this problem by making sure all possible 8-bit words are converted to a 10-bit word with no more than 5 consecutive ones or zeros. Another potential issue is the accumulation of DC errors over time for an unbalanced signal. Since the serializer and deserializer are AC coupled, a DC voltage can build up on the coupling capacitors if significantly more ones or zeros are transmitted. This buildup may eventually lead to bit errors if the logic level voltages are violated. To mitigate this problem, 8B/10B encoding ensures an equal number of ones and zeros are transmitted on average. Some GMSL devices use 9B/10B encoding for higher bandwidth, which allows 27 bits instead of 24 bits to be stuffed into a 30-bit packet. The data packets used in GMSL SerDes are highly configurable. As the number of device pins and hardware features vary for each part, the data bus is utilized differently. This example shows all the different configurations for operating in 24-bit mode. 2 bits, FCC and PCB, are used for the forward control channel and parity check, which leaves 22 bits free for video data. If a PXL CRC device is chosen and this feature enabled, 6 bits are allocated for a CRC on the rest of the packet, leaving 16 bits available for video. The DBL feature gives the option of dividing the remaining available pixels into 2 words at twice the data rate for greater p-clock flexibility. Together with the PXI CRC feature, the packet in 24-bit mode can be broken down into video data of 22 bits, 11 by 2 bits, 16 bits, or 8 by 2 bits. If a part has less than 16 parallel data inputs, it is pin limited and should be configured for double mode to avoid losing potential bandwidth. The control channel, which is used to configure both the serializer and deserializer, is designed for high flexibility. The system controller can be located either on the serializer side, the deserializer side, or both. Additionally, most SerDes devices support both UART and I2C control interfaces. Allowing different controller locations and interface modes makes SerDes parts suitable for a wide variety of configurations. In dual controller designs, with a processor on each side of the link, UART to UART control is preferable. Since many peripherals use I2C, I2C to I2C control has become the most popular. The control channel can be used to write to any register in the serializer or any register in the deserializer. This allows features to be enabled or disabled over the link before high-speed data transmission is started. An additional feature of Maxim's GMSL SerDes control channel is the ability to translate from UART to I2C. In the example shown, the serial link is used in a remote display application, with the electronic control unit, or ECU, on the serializer side, and a display on the deserializer side. The ECU controls the link from the serializer side via UART, while the deserializer is configured for I2C communication to remote peripherals. This feature allows the UART of the serializer to control a remote I2C device, such as the MAX 9850 audio DAC with headphone amplifier. Note that this application also shows how an I2S audio stream can be encoded and decoded over the serial link in addition to the video data. High-speed signals transmitted along PCB traces and the link cable suffer from high-frequency attenuation, which makes it difficult for the receiver to detect the correct ones and zeros. Preemphasis is a method to boost the high-frequency components of the signal output while leaving the low-frequency components in their original state. De-emphasis is similar to preemphasis, but consumes less power. The GMSL SerDes chipsets have programmable preemphasis and de-emphasis levels, and are specified for links up to 15 meters STP at full speed. Longer distances can be achieved if the highest pixel clock frequency is not used and with optimum pre- and de-emphasis settings. Emphasis levels are programmable to allow for up to 14 dB of pre-emphasis and 6 dB of de-emphasis. Many applications do not require both pre-emphasis and de-emphasis at the same time. To reduce EMI, one consideration is to first set the de-emphasis setting on the serializer side. After the de-emphasis setting is set, applications over 10 meters may require setting pre-emphasis. In the example shown, the signal quality is measured at the output of the serializer and at the input of the deserializer 10 meters away, with no pre- or de-emphasis. Notice how the I pattern at the output is closed at the receiver input. Due to the high-frequency attenuation, the signal quality is degraded. As the pre-emphasis setting is increased to 14 dB, the original signal is recovered at the receiver. GMSL SerDes devices also feature programmable cable equalization at the receiver. Cable equalization is similar to pre- or de-emphasis, but is located at the input of the deserializer instead of the output of the serializer. This means that the eye pattern can be almost closed at the receiver, but the data can still be recovered by applying proper cable equalization. There are 12 different EQ levels that can compensate up to 13 dB transmission line loss. The plot on the left side is an eye opening captured at the far end of 10 meters of cable and at the receiver's input at 3 gigabits per second. On the right side is the eye after receiver equalization. Output emissions are an important consideration in SerDes applications. EMI can be radiated from the board or, more usually, the cable itself. The pixel clock, repetitive signals like the video signal, microcontroller clocks in buses, and edge rates are all factors that affect EMI. Maxim serializers contain exclusive programmable spread spectrum outputs to lower emission levels by spreading the clock frequency peaks across a frequency spectrum. In addition, the deserializer can track a spread input clock, eliminating the need for multiple spread clocks. In automotive applications, signals entering the wiring harness must be able to sustain faulty conditions without damage. Safety becomes a critical concern when monitoring and detecting faults, especially in advanced driver assistance systems. Many GMSL parts are equipped with line monitoring inputs. In addition to being fault tolerant, they provide the SerDes pair with the ability to detect when the cable link is open or if there's a short to battery or short to ground condition. This information is readable from status registers available on both sides of the serial link. As a side note, the data is transmitted single-ended when coaxial cable is used. This allows one serializer differential output to be routed single-ended to 2 deserializers if desired. Many customers use coaxial cable instead of shielded twisted pair because it is lighter, thinner, more flexible, and cheaper. However, using coaxial cable is only competitive if power and data can be transmitted in one cable. To accomplish this, filtering is used to pass the electrical signals appropriately. Series capacitors are used to AC couple the forward and reverse channels. Power over coax filters use series inductors to DC couple the power component of the cable signal. Common power over coax or POC filters use inductor-resistor pairs to act as a low-pass filter across a wide frequency range, similar to using several bypass capacitors of different sizes. Since all consumed power passes through the power filter, the size and DCR of inductors becomes an important design parameter. Maxim has reference POC filters based on 3 inductors and 2 inductors, depending on efficiency and size constraints. This table represents all GMSL serializers that allow the use of both shielded twisted pair or coaxial cabling and are AEC-Q 100 qualified. Note that some devices support HDMI video applications that require high bandwidth digital content protection or HDCP. Although each serializer has an accompanying deserializer, any GMSL1 serializer is compatible with any other GMSL1 deserializer. Since each product has a different combination of features, each datasheet should outline the settings required to interface to any other GMSL1 device. This table represents all GMSL1 deserializers that allow the use of both shielded twisted pair or coaxial cabling and are AEC-Q 100 qualified. The next generation GMSL2 products offer more advanced features like 6 gigabit per second forward channel data rate, 1.5 gigabit per second reverse channel data rate, auto HDCP, DSI, OLDI, HDMI interface support, lossless compression, link diagnostic tools such as eye width monitoring, and multi-stream video audio capability. These features enable more complex solutions to meet the demand of increasing performance specifications in camera and display applications.
To summarize, in this course we have presented an overview of serial deserializer, Maxim's GMSL forward and reverse channel architecture, different features, and a summary of current GMSL products. For more information on this topic, please go to our website at www.maximintegrated.com under Products, Interface, High-Speed Signaling. We hope you enjoy this video and see you again in another educational video of Maxim Integrated.